Hello, I welcome you all to this class. Now today we are going to discuss about few derivations for moment of inertia, specifically some geometrical shape. That first we'll start to generate the formula of a moment of inertia of a triangular section. Right. So as you know that in a triangular section, the moment of inertia we are getting about the centroidal axis as well as about the base. The formula you already know that about the centroidal axis, the moment of inertia is bh cube by 36, and about the base it is the bh cube by 12. Then how it came we will see now. So first of all we have to say that you have a triangle. Okay, let's say that we'll draw first triangle one whose centroidal means moment of inertia we have to calculate about their centroidal axis as well as about the base, right? So let's say this is your triangle, right? We can give the name of this triangle that A, B and C. Okay, now say that the base of the triangle is B, okay, and the height of the triangle is which is nothing but the H, right? So height of the triangle is H. Okay, so now we have to find out the moment of inertia of a triangular section. So this is the triangle is there of ABC, having base is B and the height is H, right? So moment of inertia we will calculate about the base as well as about the centroidal axis. So first of all we will find the moment of inertia of a triangular section about the base, which is about BC. So first you can make a subheading that okay, so we can say so we can say the first we have a subheading is moment of inertia. MOI is the moment of inertia, okay, of triangular section section, right, about base, right now. So first we are finding the moment of inertia of a triangular section about the base. So for do so we have to consider one elemental strip, right, which is parallel to the BC. So here you can say that we are considering one elemental strip of having basis. This is the one elemental strip we are considering. This is the elemental strip, okay. So this elemental strip we have considered whose thickness is, let's say this thickness is the dy, right? So the thickness of the elemental strip is dy, right? Now the name you can say this name is the ABC. So this is the D and E, right? The elemental strip is D we have considered, and whose thickness is dy, right? So and this elemental strip is located at a distance of you can say y from the vertex, right? So let's say this is your vertex. So it is located, that elemental strip is located at a distance of y from the vertex, right? So this height is y from the vertex, that this is the location of the centroidal axis. So first of all, you know the moment of inertia is what? The moment of inertia of any section is nothing but the area into distance square, that perpendicular distance of the square. So here we can say that we were finding the about moment of inertia about the base, that means perpendicular distance is nothing but the vertical distance, is it or not? So first of all what we will do, we will find out the moment of inertia of this elemental strip, okay, and then we have to integrate this whatever the relation will generate, that relation we have to integrate from 0 to h, means that from lower limit to upper limit. So first of all we need to know that as we are going to find out the moment of inertia of the elemental strip, right? So first we have to find out the area of the strip. So if you look at this strip, so this strip is like a rectangle. So area of the rectangle is what? Width into dy, right? So this is what you can say, that width of this strip is dy and the thickness is width of the strip is de and the thickness is dy. De we don't know, right? So it means that for knowing this de we need to use the law of similar triangle. So you can see the two similar triangle, you can see the ADE and ABC similarities rule will apply, and then we'll get the D. So let's start that. First of all, we can say that so you can write some statement that triangular section A, B, C, D of base width is B and the height is H. So let's write very fast that triangular section A, B, C, okay, of base B, right, and height H. Is it or not? This is the consideration what we have considered the triangle whose the center of moment of inertia we have to calculate. So now you can say that you have, as you have assumed that one elemental strip, okay, of thickness dy. So now you can say that let us consider an elemental strip, right, elemental strip of what, of thickness dy, okay, of thickness dy is located at a distance of y, right, at a distance of y from vertex. So that you have considered, right, at a distance of y from the vertex. So first of all, we will find out the area of the strip. So now you can say that area of the strip, you can say that, write down the area of strip, okay. So area of a strip is what, that area strip is very small elemental strip we have, so area will be dA. Is it or not? That area of a strip dA is equal to width into thickness. Width is what, dE, and the thickness is dy. Just now we have seen. So this is dE into dy, right? So now you need to find out the dE. Okay, again you can see that from the similar triangle, that these are the two similar triangle ADE and ABC. So you can apply the similarities law. So from, you can say from similar triangle, right, what are the similar triangle you have? ADE, okay, and ABC, right. Now so you can reuse that, what, that this side by this side is equal to this height by this height, right. Now that is the side of the side by side of that ADE and ABC, and the height of the ADE and height of the ABC, okay. So now you can see, so from the similarities, that is DE by BC is equal to what, is equal to height of the ADE is y, okay, and the height of the ABC is what, that is h, okay. So now you can cross multiply. We need to find out the DE actually. Why? Because for area we have taken DE. So what the DE value we need to find? So DE is equal to, you can say, sorry, DE is equal to, you can say, DE is equal to BC times of y by h. Is it or not? So let's say that DE we calculated. Okay, now substitute this DE value into this equation of the elemental strip D, right? So we can say here, so your area of the strip will become like this, that area of a strip, right? So area of a strip is what, that dA is equal to DE into dy. So D is what, D is nothing but the BC into y by h. And if you look at here, that BC is what, BC is nothing but the base, that which is the B, right? So you can see directly that dA is equal to B y by h. B is nothing but the BC, that is the width of the actual triangle, right? So now you can got the area of the strip, dA is equal to by by h, right? So first of all, we need to find out the distance of a strip from the base. Why? Because as I told you that moment of inertia is what, that it is the product of area into square of the perpendicular distance, right? So you are going to find the moment of inertia about the base of this triangle. Is it or not? So first of all, you need to find out the distance of a strip from the base. From the base of distance of the strip is what, it is located at what distance? It is located at a distance of h minus y. Is it or not? So now you can say, the distance of a strip from the base. So Yes, so you can say here that distance of strip, that is elemental strip, from base, right, from the base. So distance of a strip from the base is what? H minus y. Alright, so now therefore you can say the moment of inertia of the strip about the base is what? Area of the strip into distance of the strip from the base squared, right? So you can say next, therefore the moment of inertia, that is MOI, of the strip, okay, about the base is equal to what? Is equal to, you can say that area of a strip into distance of a strip, right, into distance of a strip from base, into distance of a strip from where? From base, whole square. Is it or not? That is whole square. So this area of a strip into distance of base from the base of a strip from base, whole square. So you can say the area of a strip is what? That area of a strip just now you have calculated, that is by h, and distance of a strip from the base is h minus y. So when you substitute this relation, so you'll get the moment of inertia about of a strip about the base, means that a strip, that a smaller strip which you have considered whose thickness is dy, this moment of inertia, right? So you can say the dA into h minus y whole square, right? So what is the dA? dA is nothing but the by h. So you can say by h into h minus y whole square. This is the moment of inertia of a strip about the base, right? So now if I want to know the moment of inertia of the whole triangle, why? Because that this, it means that what is the significance of this strip? Significance of a strip is that, means you are considering, means you are imagining that the triangle is made up of the number of a strip, right? So number of a strip is what? Means when you assemble this type of a strip from 0 to h height, right, you'll get the triangle. Are you getting my point? Right. So it means that for one strip we have the moment of inertia of just now we calculated, which is the by h into h minus y whole square. So for whole triangle, means for number of strip is what? That how many, means what is the lower and upper limit of this triangle? The lower limit is what? 0, that at the base the height is the 0, and at the vertex the height is become h, right? So now you can say the moment of inertia of the whole triangle section. Okay, so your next is you can write that moment of inertia of the whole triangle, right? Whole triangular section, right? Moment of inertia of the whole triangular section. So what is the moment of inertia of the whole triangular section about the base? That you can say IBC, right? IBC is equal to what? That you are integrating that term from 0 to h. Which term? This term, that is by h into h minus y whole square. Is it or not? Now, so let's do the integration. So for why do we integrate this term? Okay, so you can see the this distance area is totally depends on the height and h and y, right? So b by h we can get common now, right? So sorry, this is the here area of a strip is by h into dy, right? Now this is very mistake, yes, dy we have taken here right now, so that time we forgot to write. So now you can see the area of the strip is by h into dy, right? So now we have by h into h minus y whole square into dy. This is the moment of inertia of the whole section. Right now here also you have a dy, wherever you have missed that you need to write, right? So this is what dy. So now as you are integrating this function with respect to the y, okay, it means that b by h will get common. It is constant, so let them common out, right? So you can say here that this is b by h will get out, means coming out, and the integration from 0 to h, the y will be as it is into h minus y whole square, and this is the dy. Okay, now you can open this bracket, that h a minus b whole square, a square plus b square minus 2ab. So very fast you can say that this equation will become further that b by h, okay, that integration from 0 to h, right? So it is what, y into h square plus y square minus 2hy into dy, right? So now you can say for further that b by h, right, integration of 0 to h, this y into h square plus y cube, right, minus 2hy square of dy. All right, just we have opened the bracket. So you know the y integration is what, y square by 2, y cube is y to the power 4 by 4, and y square is y cube by 3, right? So you know the whole integration, I hope so. So you can say here that this is b by h will be as it is, okay, take it out, means the bracket you can use, and then this is what, y integration is what, y square into h square by 2 plus y cube integration is what, y cube integration is y to the power 4 by 4 minus 2h, y square integration is y cube, so you can say 2h y cube by 3, right? And the limit from 0 to h, right? So when you put the upper and lower limit, so lower limit will be 0, it won't affect. So upper limit means what, this will turn h square will be h to the power 4, this will be h to the power 4, and this will also h to the power 4, means the equation will yield after substituting the limits, that is h to the power 4 by 2 plus h to the power 4 by 4 minus 2h to the power 4 by 3, right, into b by h. So now you can say here, just state that see this. So what the equation you got, that you got the equation is h to the power 4 by 2, h to the power 4 by 4 minus 2h to the power 4 by 3. So we can write down that equation, that moment of inertia of a whole triangle about the BC, that your equation will be IBC is equal to what, b by h as it is, bracket is start, and this will become h to the power 4 by 2, right, plus h to the power 4 by 4 minus 2h to the power 4 by 3, right? This is what. Now when you multiply this b, so first you can see that h to the power 4 is everywhere, so we can get it common and take it out. So this will become b h to the power 4 by h into 1 by 2 plus 1 by 4 minus 2 by 3, right? Now, so now what we will do, we can take the LCM, that this will become h, 1h will get cancelled, it become cube, so it is bh cube, right, into its LCM will be 12, right? So 6 plus 6 2s are 12, so this 4 3s are 12, so this is 3 minus 3 4s are 12, that is 8, right? So 6 plus 3 9, 9 minus 8 is 1 by 12, means that equation is bh cube by 12, right? So moment of inertia of a triangular section about the base is bh cube by 12, which you already know right now. So this is how you can get the moment of inertia of a given triangular section about the base. Next, one more moment of inertia is there, which is about the centroidal axis, right? So now copy this. Next, so here we can write continuation, that next we are going to find out the moment of inertia of a triangular section about the centroidal axis. So very fast you can go, that moment of inertia of triangular section, right, of triangular section about what, about centroidal axis, right, about centroidal axis, is it or not, right? So moment of inertia we are going to find of a triangular section about the centroidal axis. So where the centroidal axis, the centroidal axis means center of gravity of a triangle is lying at the point where their medians are intersecting. So right, so it means that if you locate the center of gravity of moment of inertia, it will be h by 3, right? Now, so now you can say that same triangle we have to draw here. So let's draw again, that let's say this is your triangle ABC, right? So this is your A vertex, B, C. The base of the triangle, let us imagine it is B, and the height of the triangle is H. Right now, the height of the triangle is H. So that just say that the centroidal axis is this one. Is it or not? Why? Because this is the point where the diagonals means medians are intersecting. So it will be center of gravity, right? So you can say the center of gravity is CG, and it is located at what distance? It is located at a distance of h by 3. Right, now we need to find out the moment of inertia about this centroidal axis. This centroidal axis, let's say this is xx. Right, so if you remember that two theorem we have studied in moment of inertia topics. Right, if you don't know, you can go through the videos. I'll share the link on the description right now. So it means that you can look at here that two axes is there. One axis is xx, it is the centroidal axis, and the one axis is bc. Right, so as you have to find out the moment of inertia about the xx axis. Right, so if you see this is the centroidal axis and this is the base. So if you find the moment of inertia about the base, right, which is parallel to the centroidal axis, we will apply what? We will apply the parallel axis theorem. Right, so what the parallel, according to the parallel axis theorem, we can say that IBC is equal to what? IG plus AH square. Is it or not? That A is nothing but the area of that section. Right, and then h is what? H is the height of the center of gravity from the base. So height of the center of gravity from the base is what? H by 3. Is it or not? So now you can say the parallel axis theorem we have to apply. Right, so before that you can consider that the triangular section of side of ABC, right, whose base is B and the height is H, that we already written right now. So now we can say the here you can say let xx is the axis, right, is the axis passing through the center of gravity, of triangular section, right, of triangular section which is parallel to base, right, section parallel to base. Right, so now we have considered that xx section passing through the center of gravity of triangular section passing parallel to the base BC. Right, so now we need to find out the moment of inertia. So further, you know, the distance of the distance between the base and the centroidal axis xx is h by 3. Right, that we already discussed, so it's better we can write also right now. So now you can say very fast, you go that the distance between BC, okay, and the centroidal axis xx is what? H by 3. Alright, now so then we can say the moment of inertia. If you have to find the moment of inertia about the base, just imagine, actually we have to find out the moment of inertia about the xx, which is the centroidal axis. Right, so moment of inertia, for finding the moment of inertia about the base, in this case what we will use, we will apply the parallel axis theorem. So according to parallel axis theorem, you can say that IBC is equal to what? IG, right, plus area into height of the center of gravity, AH square. This is the parallel axis theorem, you know already. Is it or not? No. So if you don't know, you can go through with the previous videos. I'll share the link on the description. Right, so now you can say we have to find out the moment of inertia about the centroidal axis, which is IG. So for IG we can write from that above equation, IG is equal to what? IBC minus AH square. Then the game is over. Right, no more, nothing is remain. Right, so moment of inertia about the base of a triangular section is what? Just now we have derived, which is your BH cube by 12. Just substitute the formulas and get that answer. Minus area is A and height of the center of gravity what? H by 3 over, that game is over, right? H by 3 whole square. So this is BH cube by 12, and area is what? Area is nothing but the area of the triangle is what? Area of the triangle is half into base into height. So minus half into base into height, that directly you can say BH by 2, and H by 3 whole square is what? H square by 9, right? So just simplify, BH cube by 18. So this will be BH cube by 12 minus BH cube by 18. Simplify this. So you will get the 18 as a LCM, 36. No. Yes. So it will be, its LCM will be 36. So it is 12 3 is a 3BH cube minus 2BH cube, right? So 3 minus 2 is 1. Sorry, its LCM is 36. So we'll simplify 36. 12 3 is a 36. 3 is multiplied with this, and 8 2 is a 36. 2 is multiplied with this. So this is like that. It means that this will be BH cube by 36. What? The moment of inertia about the centroidal axis, which we have to calculate, right? So you can say the ICG is equal to this one. So moment of inertia of a triangular about the triangular section about the centroidal axis is what? BH cube by 36, and moment of inertia of a triangular section about the base is BH cube by 12, which we have derived here, right? Where it is? So it is in this page only. So see here, the moment of inertia of a triangular section about the base is BH cube by 12, and the moment of inertia of a triangular section about its centroidal axis is BH cube by 36. Okay, now next we'll solve one problem which is related to the center of gravity, right? Already the center of gravity and moment of inertia is a combined chapter in almost every universities right now. So we have to solve one numerical problem which is related to the center of gravity. Means you have to find out the center of gravity of the given lamina. Okay, so the question is on the screen, that let's say a thin homogeneous wire is bent into a triangular shape, right? ABCD, such that the AB is 240 mm, BC is 260 mm, and AC is 100 mm. Look at the center of gravity of the wire with respect to the coordinate system. So actually you can see a thin homogeneous wire is there which is bent into a triangular shape ABC, so that the AB is 240 mm, BC is your 260, and the AC is 100 mm. Look at the center of gravity of the wire about with respect to the coordinate axis. With respect to the coordinate axis means what? About x axis and about the y axis, right now. So here let's imagine, first of all you can say that, just hold on. So let us say that this is your wire is there, right? This is the wire is there, is it or not? This is the wire is there, okay? And then this wire is bent into what? This wire is bent into this rectangular shape, is it or not? So this wire is bent into a rectangular shape like this, okay? So this wire is bent into the rectangular shape, right now, such that this AB is equal to 240, AC is equal to 100, and BC is equal to 260. Then you have to find out the center of gravity of that wire about the with respect to the coordinate axis, right? So here you have a one xy plane is there, this is x and this is the y. The wire is bent into this triangular shape such that it's formed ABC, right now. So AB is equal to what? AB is equal to 240, and AC is equal to 100, and BC is equal to 260, right? So first of all we can mention this dimension, that this is suppose this is your, not suppose, it is given, right? 240 mm, and this is the 260 mm, and this is your 100 mm, right? This is the 240 mm, okay? And the angle A is 90 degrees, right now. So first of all what we should do, right? So it means that if you see the center of gravity about x and y axis is what? That center of gravity actually we have calculated in terms of the area, right? That first area moment is the center of gravity, but wire is there, so for wire we need to take the length, right? So length into center of gravity of that particular means particular element plus their summation. It means what? That means x bar is equal to, we can say, L1 x1 plus L2 x2 plus L3 x3 by L1 plus L2 plus L3. Is it or not? So it means that if you have to find out that x bar is equal to what? L1 x1 plus L2 x2 plus L3 x3 by L1 plus L2 plus L3, right ma'am? And then y bar is equal to what? L1 y1 plus L2 y2 plus L3 y3 over L1 plus L2 plus L3. Sorry, right? This is the formula, you know. Actually just we have replaced the length area with the length, and the rest of the things will be same, right? So if you observe very carefully, right, so length of that let's say AB is the L1, okay, BC is the L2 and AC is the L3, right? Now so L1 is what? 240, L2 is 260 and L3 is 100 mm. But that if I want to know the AB, the centroidal axis, center of gravity about the x-axis, so it is what? Half of the length of the AB. Half of the length of the AB is not, that is whatever 240, right? So actually it is like this, that AB is inclined, right? With what angle? We don't know, that we have to find, right? Similarly the AC is also inclined. So when as this section, this element AB is inclined, we'll get the two component, that horizontal and vertical. So for horizontal, the center of gravity about the horizontal axis, we need to find out the half of the length of the component of this AB, right? And similarly for y axis, we have to find out the y half of the component of the length about of AB, okay? And similarly for AC, that x coordinate is what? X center of gravity about the x axis is nothing but the half of the length of the component of AC, right? And similarly that for y axis, the vertical component of AC, that half of the vertical component of AC, right? So first of all you need to find out the component of AB and AC. Why? Because the AB and AC is inclined. We need not to do anything with the BC, okay? Why? Because BC is exactly vertical, horizontally, right? Now so later on, first of all, for finding, means when we compute the component, we need to find out the angle. Let's say this angle is alpha, this angle is alpha, right? So if it is that, this is the triangle, right? Now so this will be the opposite, this is the opposite, this will be the adjacent, and this is the hypotenuse, right? This is not hypotenuse. Why? Because the hypotenuse is the sorry, this is not the adjacent. Why? Because the hypotenuse is always the bigger length, right? So bigger side of the triangle, okay? So now if I see that, it means that you need to find out this alpha, right? So any trigonometric terms you can use, either cos, tan or sine, right? So we can say, let's say that we are using the tan alpha. So tan alpha is what? Opposite by adjacent by hypotenuse. Adjacent is what? 240 and the hypotenuse is 260. So you can say here that cos alpha is equal to adjacent by hypotenuse. Adjacent is 240 by hypotenuse is 260. So alpha is equal to what? Cos inverse of 240 by 260. Very fast will go, just wait. That you can say cos inverse of 240 by 260. It is 22.61, right? So alpha is equal to 22.61 degree, right? Now so now you can got the alpha, so we can put it here, that alpha is equal to 22.61. It is not given, right? So if I find the component of this alpha, right? So component of this alpha is what? AB cos 22.61, and vertical component is what? AB cos sine 22.61. Now you need to find for this, we need to use this angle. So let's say this angle is beta, right? So this is 90, this is alpha, we got. So this is what, 180 minus this plus this. So you can do this, that for angle beta you have a 180 minus 90 plus 22.61. so it is what, 67.39. so you can say beta is equal to 67.39, right? Similarly for this case, cos is equal to what, no, that is beta you got right now. So now this you understood, okay? So now we can say, now you can say that L1 is what, that L1 is equal to AB, that L1 is equal to AB, which is what, which is your 240, BC is 260 and AC is 100. So this is your 240, okay, and L2 is equal to BC, which is equal to 260, and L3 is equal to AC, which is equal to 100. These all are in mm, right? These all are in millimeter, right? Now so first of all we need to find out the x1, right? So x1 is what, x1 is nothing but the half of the horizontal component of AB, right? And x2 is what, half of this, and x3 is what, half of the vertical component of this, which is the 100 mm, right? So first you can say the x1 is what, that x1 is nothing but the distance of center of gravity of AB, right? So x1 you can say the distance of center of gravity of AB, which is nothing but the what, that is half of the component of AB about x-axis. So its component is what, it's, you can say here that x component, just I'll tell you, x component is equal to L1 cos alpha, right? Now similarly for this is horizontal, we need not to find out the component. For AC, that component is what, that x component for this, it is L3 cos beta, right? So already we know. So x1 is what, distance of center of gravity of AB. So x1 is equal to, you can say the half of the x component of AB. So you can say the half of the x component of AB. Just you will understood now. X1 is equal to what, half of the x component is L1 cos alpha. So L1 cos alpha by 2, that L1 is what, 240 cos 22.61 by 2, right? So this is, so you can say 240 cos 22.61 by 2. Sorry, 240 cos 22.61, right? This half is 2, so it is 110.77. so x1 is what, that x1 is equal to 110.77 mm. x2 is what, simply half of the BC. Why? Because BC is horizontal. So x2 is equal to 260 by 2, means 130 mm. And x3 is equal to what, x3 is equal to L3 cos beta by 2, right? So L3 cos beta by 2 means what, L3 is what, L3 is 100. So you can say 100 cos 67 point, some value has came, we'll check, 67.39, right? So 67.39, this half is 2, So it is 19.22, right? That you can write 100 cos 67.39 by 2, which means that is x3 is equal to 19.22 mm, right? Similar, this is how we'll get the that is what, that is the x1, x2 and x3. Now we will find the y1, y2 and y3. So for y1 is what, for y1 is nothing but you have you can say the L1, vertical component of L1. Vertical component of L1 is what, that sine alpha by 2. And for x2, we have a y2 is 0. Why? Because the element 2 is kept horizontal, right? So there is no vertical distance. For x3, this is L3 sine beta by 2, y3, right? So here you can say that y1 is equal to L1 sine alpha by 2, right? And y2 is equal to 0. Why? Because that BC is kept horizontal, right? And y3 is equal to L3 sine beta by 2, right? So L1 is what? L1 is, you have a 240, yes, sine 22.61 by 2, right? This is 0, and this will be 100 sine 67.39 by 2, right? So we'll put the values. First we'll substitute that 240 sine 22.61, answer divided by 2, which is 46.13. so this is the 46.13, right, mm, and this is the 100 sine 67.39. so you can say 100 sine 67.39. this is 92 divided by 2. This is also same, right? So this is 46.13, right? Now, so then we can substitute these values into the equation, that is x bar is equal to what? X bar is equal to L1 x1 plus L2 x2 plus L3 x3 by L1 plus L2 plus L3, and y bar is equal to that, right? So now you can substitute here. So very fast you can see that, so you can say that x bar is equal to what? L1 x1 plus L2 x2 plus L3 x3 by L1 plus L2. L1 is what? L1 is 240 into x1 is 110.77 plus L2 is 260 into this is 130, right, plus L3 is 100 into this is 19.22, right, by 240 plus 260 plus 100. We'll get the x coordinate in millimeter, right? Then y bar is what? L1 y1 plus L2 y2 plus L3 y3 by L1 plus L2 plus L3. So L1 is what? 240, y1 is 46.13 plus L2 is 260, but y2 is 0, right, plus L3 is 100 into this is same 46.13 by 240 plus 260 plus 100. We'll get the y bar, right? That is also in mm. So for the given lamina with the wire which is bent into a triangular shape of ABC, of AB is equal to 240, BC is equal to 260 and AC is equal to 100 mm, his center of gravity about with respect to their coordinate axis x bar comma y bar is equal to you have a 140.77 comma 26.154, right? So this is your answer. Okay, so this is how we can find out the center of gravity of given body, right? So this is all about the today class. Thank you.